Hello and welcome to another Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 5, Lesson 3 on what are known as the logarithm laws. Now logarithms are pretty new, right? And we've only seen them in 2 lessons so far. Make sure that this isn't your first lesson on logarithms or it's going to get awfully confusing. Let's jump right into logarithm laws and see what they are. Alright, exponent and log laws. Logarithms have properties, just as exponents do, that are important to learn because they allow us to solve a variety of problems where logarithms are involved. Since logarithms give exponents, right, as outputs, the laws that govern them should be similar to those that govern exponents. Below is a summary of these 3 laws. And back in the last unit, we reviewed the exponent laws. So let's keep it right here, right? Every one of the exponent laws has an equivalent log law. So the product law for exponents says when we multiply 2 things with the same base, we can add their exponents. On the other hand, the logarithm version says when we take the logarithm of a product, we can actually add the 2 logarithms of each part of the product. There's a quotient rule for exponents that says when we divide 2 things that have the same base, we can subtract their powers, specifically that we can subtract the power of the denominator from the power of the numerator. The logarithm version of that is that when we take the logarithm of a division, we can then subtract the 2 logarithms. We're literally subtracting exponents here, right? Logarithms are exponents. So here we're adding exponents because we multiply. Here we're subtracting exponents because we divide. Now the final one, which is ironically probably the most important both exponent law and log law, in the exponent it's called the power law. That's when we have something raised to a power raised to another power, we can multiply the 2 powers. The logarithm version is a little bit more difficult to see how it is similar to this, but here if we take the logarithm of something raised to a power, we can simply find the product of that power with the logarithm of the base. All right, and that really is, because logarithms give us powers, the product of 2 powers. Y is a power, an exponent, and so is the log base b of x. It's also a power. All right, now in today's lesson, we're going to just get some very rudimentary work with these log laws, and we're going to eventually use the power law quite a bit. You'll get more exposure to the product and the quotient laws of logarithms in your pre-calculus course next year, but we wanted to give you some initial exposure to them in this course. So let's jump right into exercise number 1 and take a look. Which of the following is equal to the log base 3 of 9x? All right, well, what we see and what we want to look at all the time when we're trying to use a log law is we want to look at what's, quote, inside of the logarithm. That's known as the argument of the log function. And right now what we have is a product. And we have this rule up top that says that the log base b of x times y is equal to the log base b of x plus the log base b of y. So what I can do with this particular expression is I can say that the log base 3 of 9x is equal to the log base 3 of 9 plus the log base 3 of x. Now, there's nothing that I can really do with the log base 3 of x right at this point, but I can say that the log base 3 of 9 is equal to 2. Why? Because 3 to the second equals 9. So this is all 2 plus the log base 3 of x. Choice 3. All right, now, I never want you to forget that when we do a manipulation using what's known as a law or identity, right, then what we're always saying is what's on the left-hand side is equivalent to what's on the right-hand side. And that equivalency can be tested. So let's take a look at exercise number 2. Test the equivalency of the original expression and your choice from exercise number 1 using x equals 81 and x equals 1/27. Show the substitution into each expression and their values. So again, my claim is we can actually test to see whether this and this are equivalent by using, sort of convenient values of x. Here's what I mean. Let's do x equals 81 together. All right? So for x equals 81, our original expression was the log base 3 of 3 times 81, all right? And that's the log base 3 of 243, all right? Now, that might be a little bit tricky. Of course, you've got your calculator, so you could certainly take the calculator out, right? We could grab our calculator. We could maybe add a different page so we're not looking at that. And we could do the log base 3 of 243, and that's equal to 5. Of course, meaning that 3 to the 5th is equal to 343. So that's equal to 5, right? But we're saying that, hey, that should be the same as 2 plus log base 3 of x. Well, 2 plus log base 3 of 81 is going to be 2 plus, and let's see, log base 3 of 81 is 4. Somehow that didn't work out right. 2 plus 4, oh, I see why. We'll get there, which is 6, and those aren't the same, all right? And the reason that they're not the same is for some reason I didn't test log base 3 of 9x. I, for some reason, tested log base 3 of 3 times x, and I apologize for that. That's 9 times 81, which is not 253. It's 729, and if I did, everyone's going, why did he do that? Log base 3 of 729, and that's 6. Hey, we all make mistakes, and we learn from them. So that's equal to 6. So that works out well, right? And it shows us that at least for x equals 81, this expression and that expression, not a totally different one, are equivalent. Why don't you go ahead and try to do something similar for x equals 1/27th. Test that one in both. Pause the video now. All right, well, let me see if I can do the correct one here. So for my original expression, which was the log base 3 of 9x, I'm going to have 9 times 1/27th, which is the log base 3 of 1/3, and that is equal to -1, right? 3 to the -1 is equal to 1/3. On the other hand, if I do it in this particular expression, 2 plus the log base 3 of 1/27th. Log base 3 of 1/27th is -3 because 3 to the -3 is 1/27th. 2 plus -3 is -1. That one I didn't even need to use my calculator on, but I could. All right, let's keep working with log laws. The point in these two tests is to hammer home that I'm not just manipulating, right? I'm manipulating to come up with an equivalent expression, probably for some reason to solve some problem, right? Here, I'm just kind of playing around with it. All right, let's keep going. So, exponent and log laws, again, we show them right here so that we kind of have them in front of our face. Let's take a look at exercise number 3. The expression log of x squared divided by 1,000 can be written in equivalent form as which of the following? Now, if you're looking at this and you're saying, wait a second, what is the base of this logarithm? Remember, when the base of the logarithm is not written, it is what's known as the common log or base 10, log base 10. That's what we have here. Now, the first thing I do is I again look inside of the logarithm, look at the structure of what's in there. And what I see in there is a division problem, right? So I know that the log of, let's say, a divided by b is going to be the log of a minus the log of b. So the first thing I can do here is I can say that this is going to be the log of x squared minus the log of 1,000. Okay? Log of x squared minus log of 1,000. Now, log of 1,000, because this is actually base 10, log of 1,000 is 3, because 10 to the third is 1,000. But what do I do with this? Well, we're told, using this particular law, that the log base b of anything of x to the y is y times log base b of x. What basically this logarithm law does is it says any time I take the logarithm of a quantity raised to an exponent, I can basically just take that exponent out of the argument of the logarithm and turn it into the product. Log of x squared equals 2 times log of x. And then we get the minus 3 from the fact that I have log base 10 of 1,000. All right, great. By the way, that looks like a subtraction. It's really an equality up there. I just sort of realized that. I apologize. All right, let's do a little bit more. Still, same exponent laws, just getting them in there. Now let's take a look at one that kind of gets some roots and stuff going on. Exercise number 4. Which of the following is equivalent to log base 2 of the square root of x divided by y to the 5th? All right, what I'd like you to do is play around with this a little bit. This is actually pretty similar to the last one that we just did in structure and sort of practicality. So play around with it a bit and see what you got. All right, well, just like before, the overall structure of what's inside of the logarithm is a quotient. It's a division problem. Therefore, we can find the logarithm of the numerator, the logarithm of the denominator, and then subtract the two. So the first thing I'm going to do is I'm going to say that this is log base 2 of the square root of x minus log base 2 of y to the 5th. All right, and that's just using that second log law. That's it. Now, we could certainly use the third log law, the one having to do with exponents, this one, to simplify this, right? So the log of log base b of anything, of something raised to an exponent, I can just pull that exponent out. So here I can literally write this as 5 times the log base 2 of y. All right, just pull that exponent out. That's exactly what this log law says to give me this. I can just pull that out. But what do I do with log base 2 of square root of x? There is nothing in here that says what the logarithm of a square root is, except that square roots are the same, right, as fractional powers. So the log of the square root of x is the same as the log of x to the 1/2, right? The square root of x and x to the 1/2 are the same, and therefore I now have it as the logarithm of a quantity raised to a power. I can bring that power out front. That becomes 1/2 log base 2 of x minus 5 times the log base 2 of y, and that is, of course, choice 3. All right, the key there is to recognize, of course, that square roots are the same as the 1/2 power. Okay, let's take a look at another one. Exercise 5. Suggest values for x and y that would work well to check your answer from exercise number 4, and then use them to check. Explain why you chose your particular values. So in other words, what I'd like to do is I would like to see if I've got the right choice here, right? Now, in order to do that, what I need, kind of like a few problems ago where we had x equals 81 and x equals 1, I think it was x equals 27 and x equals 81. Anyway, whatever it was, x equals 81 and x equals 127. I need to choose particular values of x and y that might make it easy to check this, all right? So think about that a little bit and maybe just consider looking at this, numbers for x and y that would be easy to find the logarithm base 2 of that number. Pause the video now and see what you can do. Well, there's tons of different choices, right? But what we kind of want is we want powers of 2, right? Powers of 2 would be really nice. So powers of 2 are like 2, 4, 8, 16, 32, etc., right? So maybe what I do is I say, you know, x is equal to, and also, another thing, you know, I'm going to have to take the square root of x, all right? So I kind of want x to be a perfect square. So maybe x is equal to 4. And y is fine, but y is kind of, you know, I'm going to have to raise y to the 5th. So maybe y will be equal to 2. right? And again, I'm using these two values specifically because both of these are natural whole number powers of 2, and I've got to take the square root of, x. So if I want to check this, it's best if I can take the square root of a nice number. So let's just, let's check these two. Here's the equivalency. Let's first put x equals 4 in here and y equals 2 here. So that's going to be the log base 2 of the square root of 4, all divided by 2 to the 5th. All right, that's going to be the log base 2 of 2 divided by 32. Let me extend it. That's going to be the log base 2 of 1/16. And the log base 2 of 1/16 is -4 because 2 to the -4 is equal to 1/16. All right, great. Now what I want to do is I want to put in exactly the same numbers, but in here. 1/2 log base 2 of 4 minus 5 times log base 2 of 2. All right, well, the log base 2 of 4 is equal to 2 because 2 to the second is 4. And the log base 2 of 2 is equal to 1 because 2 to the first is 2. 1/2 times 2 is 1. 5 times 1 is 5. And 1 minus 5 is -4. All right, that gives us some confidence that we in fact have the right equivalency. Okay, let's take a look. Still more logarithm laws. Exercise number 7. The logarithmic expression log base 2 of the square root of 32x to the 7th can be written as which of the following? All right, well again, play around with this. Try to look at the argument of that logarithm, understand what its larger structure is, and then try to use the logarithm laws to see which one of these is the correct expression. All right, this can be very tricky, right? What I've got is the log base 2 of something underneath the square root. All right, so that's the bigger structure, right? Is that what I've got is the logarithm base 2 of something, which is this thing, raised to the 1/2. And maybe I'll do that, right? Lots of parentheses there. So the first law I'm going to use is actually this power law, which says if I take the logarithm of something raised to a power, that something being 32x to the 7th doesn't really matter. But if I take the logarithm base 2 of something to the 1/2, I can bring that 1/2 out. All right, and then I have the log base 2 of 32x to the 7th. Let me extend my page a little bit there. Okay, so now what I've got inside of here, fundamentally, is the logarithm of a product, the product between 32 and x to the 7th. So, being very careful about my parentheses, I can now say that that's the log base 2 of 32 plus the log base 2 of x to the 7th. All right? And now, what can I do inside of this parentheses? Well, conveniently, 32 is 2 to the 5th power. So all of this is equal to 5. On the other hand, this is the logarithm of something raised to a power, so I can bring that power out, and that's going to be plus 7 times log base 2 of x, all times 1/2. Now, is that one of my choices? Well, I've got 5 plus 7 log base 2 of x times 1/2. Here I've got 5 plus 7 log base 2 of x divided by 2. These two things are the same, right? Multiplying by 1/2, dividing by 2, same thing. All right, let's take a look at one more. Bring this somewhere. So let's take a closer look at the third law and try to move that out of the way. Logarithm laws are important for future study in math and science. Being fluent with them is really quite essential. Arguably, the most important of the three laws is the power law. In the next exercise, we will examine it just a bit more closely, because it is kind of the most mysterious of them at all, right? This law that says, if I take the logarithm base b of something raised to an exponent, I can literally bring that exponent out. Exercise number 8. Consider the expression log base 2 of 8 to the x. Using the third logarithm law, the power law, Rewrite this as an equivalent product and simplify. All right, well, why don't you go ahead and do that? Try to use that law, the power law, to rewrite this as a product, right? That's the product right there, and then simplify anything you can simplify. Go ahead and do that. All right, well, let's take a look. This is the log base 2 of 8x. Oh, no, sorry, not 8x, of 8 to the x. 8x is totally different. 8 to the x. So that's x times the log base 2 of 8, according to that third law. Now we can do a little simplification here because the log base 2 of 8 is equal to 3, right? So all of this will be 3x. Log base 2 of 8 to the x simplifies into just 3 times x, which is really cool. But now let's take a look at letter B. Show that log base 2 of 8 to the x is equal to 3x by rewriting 8 as 2 to the third. All right, well, pause the video now and see if you can figure out what we're getting at here. All right, well, 8 is the same as 2 to the third. So I can rewrite this thing as 2 to the third to the x, right? Because all I'm doing is rewriting 8 as 2 to the third. But now I can use the product property of exponents to rewrite 2 to the third to the x as 2 to the 3x. And now I can answer this question or evaluate this using the fundamental definition of a logarithm. What do I have to raise 2 to in order to get 2 to the 3x? Well, I've got to raise it to the 3x. All right. And believe it or not, that really is kind of showing you why this particular property works. All right. Probably doesn't convince you, but it's getting there. All right, let's wrap this up. So logarithm laws, and I'd love to get into the history of logarithms because this is really it. Logarithm laws really allow us to use the property of exponents, but sort of in the logarithm land or the logarithm space. For every exponent law, even ones that we didn't look at right now, there is an equivalent logarithm law. The most important of which is most certainly that third logarithm law that says if we take the logarithm of a quantity raised to an exponent, we can rewrite it as that exponent times the log of the quantity. And we'll see how that's particularly useful when we solve equations involving logarithms and exponentials in our next lesson. For now, I just want to thank you for joining me for another Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.